Hello there and welcome to A2 Maths. This is Specimen Paper 1 and here we're looking at question 14, the final question on Specimen 1, before we move on to Specimen 2 of course. So figure 6 shows a sketch of the curve C with parametric equations x equals 4 cos t plus pi by 6 and y equals 2 sin t. Show the Cartesian equation of C can be written in the form of this expression here, where a and b are integers to be found. Right, okay, the first thing I would probably want to do is rewrite x as a double angle formula. So I would want to write it as cos of t, cos of pi by 6, I'm using the angle addition formula here, minus sine of t, sine of pi by 6. Now pi by 6, remember, is 30 degrees. We all know our 30-degree angles off by heart. This is going to be 4 cos of pi by 6, that is root 3 over 2, so it's going to be 4 root 3 over 2, so it'll be 2 root 3 cos of t. And then sine of pi by 6, sine of 30 is a half, so this is going to be minus 2 sine t. Right, okay, so now what we need to do is we need to create this expression here. We're going to need to create x plus y all being squared plus ay squared plus b. Let's just start with the x squared plus y squared part. So x squared plus y squared is going to be 2 root 3 cos of t minus 2 sine t, and then that's going to be plus y, so that would be plus 2 sine t, and that's all going to be squared, so this is going to be x plus y all squared. So this is going to turn into, well, that and that will cancel, so it's just going to be 4 times 3 is 12, so 12 cos t is going to be, sorry, 12 cos squared t is equal to a squared, so x squared plus y squared. Now, what we need is for something squared to add together to make something squared to equal just a numerical constant b. What I'm guessing is that we need something like cos squared plus sine squared equals 1 here, or some scalar multiple of that. So what I'm thinking is that a is going to be the number 6, and then b is going to be the number 12. So if I set a equal to 6, then ay squared is going to equal 6 times 2 is 12 sine. Oh no, wait, the y needs to be squared, so I'm actually going to set a equal to 3, because then I'll have 3 times 4, that will make me 12 instead, so it's going to be 12 sine squared t. And then 12 cos squared plus 12 sine squared, so therefore a squared plus x squared plus y squared plus ay squared will equal 12 cos squared t plus 12 sine squared t, and that will obviously equal 12 from pulling out a factor of 12, and then cos squared plus sine squared equals 1. So there we are then. So therefore a is equal to 3 and b is equal to 12. Lovely, there we are. So that key to this question was just spotting that inside this question you needed to use cos squared plus sine squared equals 1, and at the start as well you needed to expand this cos t plus pi by 6, and then that really helped things later on. So there we are, that's the answer to question 14, 5 marks for that question, and now it's time to move on to specimen paper 2. Lovely, thanks for watching.